Okay, hello everyone and welcome to this video. In this video we're going to be looking at SACE Stage 2 Chemistry, subtopics 4.3 and 4.4, so we're going to be looking at aldehydes and ketones and alcohols. So what we're given here are three different compounds, compounds A, B and C, and we don't know which one is which in the test tube sample. So we need to try and work out what tests we could do to work out which one's A, which one's B, and which one's C if we were given them in test tubes in front of us and we didn't know which one was which. So really we're looking at functional groups and the behavior of functional groups when we do certain chemical tests. So let's have a look at compound A here. We can see clearly that the key functional group here is a ketone functional group, and because we can see that we've obviously got a carbonyl group there. With this one, we can see that the key functional group is an aldehyde functional group, because we have a C double bonded to an O and we have a hydrogen there. Lastly, we can see that this is a primary alcohol. We can see that because we've got one carbon there and that carbon is bonded to another carbon, but only one other carbon. So as a result, we need to start thinking about what we can actually do that will start eliminating the suspects and eventually get us to our conclusion. So the very first test that comes to mind is the dichromate solution test. So we obviously know dichromate solution generally contains hydrogen ions as well, but we know dichromate to be Cr2O7 2-, so chromium ions, oxygen ions, and it has an overall negative charge. So what we could do is we could try adding some dichromate solution to all of these compounds within our test tubes. And let's think about what would happen here. So let's start by considering what would happen with the ketone. Now ketones are very hard to oxidize, so as a result we wouldn't expect the dichromate to oxidize that functional group in any way. So as a result, we wouldn't really expect anything to happen for that chemical test. If we would add dichromate to compound A, nothing would happen. If we added it to compound B, we have an aldehyde functional group, and the aldehyde functional group can be oxidized. So as a result, what will happen is we will get the formation of chromium 3+ ions. This means that our dichromate solution has been reduced to chromium 3+ ions, and because of this we can actually see a color change, because we know that dichromate solution is going to be a very nice orange kind of color. But when we actually have the reduction take place, and we know that an aldehyde will get reduced under acidic conditions, which are these conditions, because we're using dichromate solution here, it's under acidic conditions, we're going to have the formation of a carboxylic acid functional group. But as a consequence of this at the moment, we are going to get green chromium ions as a result of the reduction that's taking place. Because remember, with redox reactions, we have reduction and oxidation occurring simultaneously. So we would have a color change from orange to green there. That would be a qualitative thing that we could recognize from our chemical tests. And the same with the alcohol. The primary alcohol will be oxidized to an aldehyde, and if left long enough will oxidize again to a carboxylic acid. But it means that our dichromate solution will be reduced into chromium ions, and as such our orange solution will appear more green in color because of that reduction that's taking place. So now we can see that if we add dichromate and we get nothing happening, we can immediately identify compound A within the test tube. So compound A would be identified by having nothing happen. And that leaves us with B and C. So let's say we have 3 test tubes, one with each one. We've cancelled out one, so we've got 2 test tubes left, and we need to try and work out what's going on. So we need to work it out what's going to happen with a primary alcohol and with just an aldehyde group here. And this is where we can use the Tollens reagent. Now Tollens reagent will help us because we can do what's known as the silver mirror test. So the Tollens reagent is actually given by the following formula here that we can use. It's given as being silver. It obviously contains silver because we're going to have a nice silver mirror formed, but it's silver ions at the moment. And we've got NH3 and NO3. So now we can add Tollens reagent to both compound B and compound C, or the two remaining test tubes. We don't know which one's which. And what would we expect to see happen? Well, we could see that the aldehyde would actually react with Tollens reagent, and this would be known as alkaline conditions. So what we'd actually have as a result of this reaction with alkaline conditions, because we have the Tollens reagent, is we'd have the formation of a carboxylate ion. And a carboxylate ion, I'll give the general form here. We can see that there's an O- and there's a double bond O. What this actually means in terms of what happens to the Tollens reagent here is we have the formation of silver ions. This formation of silver metal from the ions. And the formation of silver metal means that we will actually be able to see the silver metal within the test tube, and it will form a silver mirror film. So as a result, if we see a silver mirror film, because the same thing doesn't happen when we add when we add Tollens reagent to a primary alcohol, we can immediately identify that if we do see silver, we have obviously got compound B within that test tube. So hopefully this has been an okay video to describe some of the chemical tests that we could use and observations. Didn't quite write out many of the annotated equations. I got the general ideas down here, but yeah, that's the process for answering this kind of question. Hopefully that helped. Thank you for watching this video.